Okay, you're going to, or I am, show you how to do an enlargement, one of the four transformations using Dr. Frost. So I could go through 60 questions, by which time you'll be sound asleep, all stupid, and that's probably not a good idea. So I'm only going to do a couple of them. And you can do hundreds and hundreds if you want. Well, let's have a look at what we've got here. The idea of an enlargement is making an object bigger. You keep its similarity. So here we've got a small object and a big object. The big object has a scale factor of 3, which means it is 3 times bigger. Why? Because it's 2 across, whereas this is 1, 2, 3, 4, 5, 6. And 6 divided by 3 by 2 rather is 3. So I'll just put in the scale factor of 3. Whoopee, I'm right. Okay. 6 divided by 2 is 3. Next question. Now this one's a little bit more fun. It says enlarge the shape by a scale factor 3 about the point -42. So the first thing I'm going to do is to move this little dot to -4, which is here. Okay, -4, which is left, and 2, because it's positive, is up 2. Okay. And we want a scale factor of 3. So what we do now is we imagine you are shining a light across this object, and the beam throws a shadow, which is very realistic because this sort of dark stuff is rather like a shadow. Now what I'm going to do is I'm going to look at these points here, right, which make up the corner of the triangle. And to go from the point here to this point, I would go 1, 2, 3. So as it's a scale factor of 3, I'm going to multiply that by 3 and go 9. So 1, 2, 3. That's a scale factor of 1. 1, 2, 3. That would be a scale factor of 2. 1, 2, 3. That would be a scale factor of 3. Mission accomplished. Right, what about this point here from the red dot? Well, that's only 1. So, oops, I don't move that one. I move this one. So that goes 1, a scale factor of 1, 2, 3. Now the point is here is that I go 1 across, but nothing down. So 1 times 3 is 3. Now, what about this one? Well, now this is the important one. We're going 1 across and 2 down. 1 across, 2 down. So multiply both by 3. So instead of going 1 across and 2 down, we go 3 across, 1, 2, 3, and 6 down. 1, 2, 3, 4, 5, 6. Now, have we in fact scaled this up 3 times? In other words, is every side 3 times longer than the original object? Well, this was 2, this is 6. Now, obviously it's 6 because 2 times 3 was 6 and we went down 6. And this is 1, 2, and this is 1, 2, 3, 4, 5, 6. So I think I've got it right. And Dr. Frost agrees. So he said the center, and he's confirmed. So let's do the next question. Don't worry, 57 more to go. Look at this one. Well, we want to go from the little object to the big object. So the triangle is an enlargement of triangle P. Calculate the scale factor of this enlargement. Well, this is 1, and this is 1, 2, 3, 4. So this is 4 times longer than that. There's your answer. Okay, next question. Well, we're going to enlarge a shape by a scale factor of 3 again. All right, so where do we put the red dot? We put it at the point 4, -1. 1, 2, 3, 4, because that's positive. So we go to the right. -1, we go down to this point here. Okay, now it's a factor of 3. So to get from 1 to this point, we go 2, 1, 2. So that's a factor of 1, 1, 2. That's the second factor. 1, 2. There's my third factor. Now what about this one? 1, 2, 3. Okay, so 3 3s are 9. So I've already done 3. 1, 2, 3. That's 6. 1, 2, 3. There we have it. Now then, what about this one? 1, 2, 3 across and 1 down. So that now becomes 9 across and 3 down. 9 across and 3 down. Bing. Easy, isn't it? Okay. Well, hopefully that wasn't too difficult. Now, you'd have a go a load of yourself, do a load yourself, okay?